Section 7.5 Solving Trigonometric Equations. In this section, we are going to learn how to solve for an unknown in a trigonometric equation. Example 1. Find all possible exact solutions for the equation cosine of theta equals 1/2. We have an equation cosine of theta equals 1/2. In this equation, theta is the unknown, and they asked me to find all of the possible exact solutions for theta. That means I'm looking for the value that I can replace theta so that cosine of the value equals 1/2. I am including the unit circle here, but you are expected to know your unit circle. Cosine of theta equals 1/2. 1/2 is positive. When cosine of an angle is positive, the angle is either in the first quadrant or the fourth quadrant. So, in the first quadrant, cosine of pi over 3 equals 1/2. And in the fourth quadrant, cosine of 5 pi over 3 equals 1/2. In another word, if I substitute theta with pi over 3, cosine of pi over 3 equals 1/2. Or if I substitute theta with 5 pi over 3, then cosine of 5 pi over 3 is also equal to 1/2. At this point, I am going to ask myself, are these all of the possible solutions that I can have? If the question is asking for all possible answers from 0 to 2 pi, then these are my answers. But they didn't ask so. They asked for all possible exact solutions, which means in the whole entire domain. So, pi over 3 and 5 pi over 3 are my solutions in one cycle from 0 to 2 pi. But my domain doesn't stop at 2 pi. It can just keep going and going. So if I rotate 1 pi from 0 to 1 pi, this is my answer. And then from pi to 2 pi, this is my answer. And what if I just keep rotating? I will keep having 2 answers for every 2 pi. So my answers are pi over 3 and pi over 3 plus any 2 pi. Also 5 pi over 3 and 5 pi over 3 plus any 2 pi. Because it will get to this point for every cycle. K represents an integer here. If k is 0, you have the answer is pi over 3. If k is 1, you have pi over 3 plus 2 pi. If k is 2, you have pi over 3 plus 4 pi, and so on. In this question, they're asking for exact solutions. That's why we leave the answer as pi over 3, 5 pi over 3. We don't convert that into decimal. If they ask for a decimal, they will tell you how many places they want you to round to. Example 2. Solve the problem exactly. 2 times sine squared theta minus 1 equals 0. Theta is in between 0 and 2 pi. In this question, they only want the answer in between 0 and 2 pi, which means from here all the way to here. They don't want you to keep rotating. And I'm supposed to solve for theta. Whenever I'm having a trigonometric equation, I will try my best to solve for this trigonometric function here. In another word, I try to isolate the trig function. I want to have sine of theta on one side, and everything else is on the other side. So what I'm going to do first is going to add 1 to both sides. I'll have 2 sine squared theta equals 1. Then I am going to divide both sides by 2. I'll end up with sine squared theta equals 1/2. Then I am going to take square root on both sides. And when taking square root on both sides, don't forget the plus or minus. Sine theta equals plus or minus 1 over square root of 2. I will rewrite this so that it will match the number on here. Instead of 1 over square root of 2, I will rationalize the denominator to make it root 2 over 2. So I have sine of theta equals either positive root 2 over 2 or negative root 2 over 2. When sine of theta equals to positive root 2 over 2, theta is going to be on the first and the second quadrant, because when theta is on the first or second quadrant, sine of that angle is going to be positive. And I'm looking into my first and second quadrant to see which angle that makes my sine equals to root 2 over 2. And that is pi over 4 and 3 pi over 4. Sine of theta equals to negative root 2 over 2 is when my theta is in the third and the fourth quadrant. This is where my sine is negative. And in the third and the fourth quadrant, at the angle 5 pi over 4, my sine is negative root 2 over 2, and also at 7 pi over 4. In this question, I have 4 different solutions that are in between 0 and 2 pi that makes 2 sine squared of theta minus 1 equals 0. Example 3. Solve the equation exactly. Cosecant of theta equals negative 2. Theta is in between 0 and 4 pi. My equation is cosecant of theta equals negative 2. My unknown is theta. I'm supposed to find the value of theta that satisfies this equation. And my theta is in between 0 and 4 pi. In this equation, I have my trig function is by itself, and then everything else is on the other side. From here, I'm trying to solve for theta. On my unit circle, I only have the value for cosine and sine. I don't have the value for cosecant. What I am going to do now is rewrite cosecant theta into 1 over sine of theta. And from here, I am going to solve for sine of theta. So I'm going to multiply sine of theta on both sides to have 1 equals negative 2 sine of theta. And then I'm going to divide both sides by negative 2. So I have sine of theta equals negative 1/2. From here, I'm looking for the angle theta, so that sine of that angle equals negative 1/2. Sine is negative is when the angle is in the third and the fourth quadrant. When theta is 7 pi over 6, sine is negative 1/2. And when theta is 11 pi over 6, sine is also negative 1/2. In the cycle from 0 to 2 pi, if theta is 7 pi over 6 or 11 pi over 6, that will satisfy this equation. However, they want to have the answer from 0 to 4 pi. That means you repeat the cycle twice. So the first answer is 7 pi over 6, 11 pi over 6, 7 pi over 6 plus 2 pi, 11 pi over 6 plus 2 pi. Seven pi over 6 plus 2 pi is 19 pi over 6, and 11 pi over 6 plus 2 pi is 23 pi over 6. In this problem, when theta is in between 0 and 4 pi, I have 4 different solutions. This question, they asked to have exact solutions, so I will leave my answers like this. I don't put that into calculator to get decimals. Again, only give decimal answers whenever they ask for it. If they ask for decimal, they will tell you how many decimal places you need to round to. Example 4. Identify all exact solutions to the equation. 2 times tangent of x plus 3 equals 5 plus tangent of x. X is in between 0 and 2 pi. In this equation, my unknown is x. I'm supposed to find x, and my x values is in between 0 and 2 pi. In this equation, I have tangent on the left side and tangent on the right side. What I'm going to do next is trying to simplify the left-hand side here by multiplying the 2 out. So I will have 2 tangent x plus 6. Next, I am trying to bring the tangent to one side. I can bring 2 tangent from here to the right side or tangent from here to the left side. It doesn't matter. So I'm going to go ahead and bring this tangent from the right side to the left side by subtract tangent from both sides. 2 tangent x minus tangent x is tangent x plus 6 equals 5. From here, I am going to subtract 6 from both sides to get tangent equals -1. I have the equation of tangent of x equals -1. I try to find the value of x that makes tangent of that value equals -1. Tangent is negative when my angle is in the second quadrant and the fourth quadrant. When you look at your unit circle, they don't tell you the value of tangent. They only tell you the value of cosine and sine. So whenever you want to find the value of a tangent, you take sine divided by cosine. So I'm going to take sine divided by cosine, 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 sine divided by cosine. And I'm looking for the one that gives me -1. That is at 3 pi over 4 and 7 pi over 4. So in one cycle from 0 to 2 pi, at 3 pi over 4 and 7 pi over 4, it will satisfy this equation. Example 5. Use a calculator to solve the equation sine of theta equals 0.8, where theta is in radian, round to 4 decimal places. My equation is sine of theta equals 0.8, and they told me that theta is in radian, not degree. This is very important. And they also want me to round the answer to 4 decimal places. Sine of theta equals 0.8. 0.8 is positive. That means that theta is in the first or the second quadrant. When theta is in the first quadrant, sine is positive, and when theta is in the second quadrant, sine is also positive. So 0.8 is here and also here. How do I know that it's here? Because when I put √3 over 2 in the calculator, I got 0.866. And when I put √2 over 2 in the calculator, I got 0.707. So 0.8 is in between the two. So I'm supposed to find the angle here and the angle here. And I need to use my calculator. So I have sine of theta equals 0.8. To find theta, I need to take sine inverse of 0.8. And from here, I need to use a calculator for this. You can use any kind of scientific calculator that comes with trig and trig inverse. And here, I'm just going to calculator.net and use this calculator. So the first thing you're going to do is choose the correct mode. Remember, your theta is in radian, so I'm choosing radian instead of degree. And then I need to find sine inverse, so hit sine inverse of 0.8. My answer is 0.927295218. And the answer asked me to round to 4 decimal places. So that is equivalent to 0.9273. I am supposed to have two different values for theta. One is in the first quadrant and one is in the second quadrant. The calculator only gave me the answer in the first quadrant, which is 0.9273. The angle from 0 to this red ray is 0.9273. And this is 0.9273 radian, not degree. Now, I need to find the angle from 0 to this green ray right here. I need to find that. I don't know what that is, but I know this is equivalent to 0.9273 right here. And I know from 0 to here is 1 pi. So if I know that this is 1 pi and this is 0.9273, then this green angle is pi minus 0.9273, which is equivalent to 2.2143. These are the two answers if theta is in between 0 and 2 pi. However, in this problem, they didn't say so. That means theta is in the set of all real numbers. That means the solution will repeat after every 2 pi's. So my solutions are 0.973 plus 2 pi k and 2.2143 plus 2 pi k. And make sure that k is an integer. And these answers are in radian. Example 6. Use a calculator to solve the equation secant of theta equals -4. Given your answer in degrees and round to 2 decimal places. My equation is secant of theta equals -4. I want the answer in degrees and round to 2 decimal places. Secant of theta equals -4. Secant and cosine are negative on second and third quadrant. I will first convert this into cosine, so that's going to be easier for us to work with. I will rewrite secant of theta to 1 over cosine of theta. Next, I am solving for cosine, so I'm going to multiply both sides by cosine to get 1 equals -4 times cosine of theta. And then divide both sides by -4 to have cosine of theta equals -1/4. Cosine of theta equals -1/4. It should be somewhere in here and in here. To find theta, I am going to take cosine inverse of -1/4. And I am going to use calculator for this. First, I need to choose the correct mode for this problem. This problem wants the answer to be in degree, so I need to change it to degree. And I'm going to use cosine inverse of -1 over 4. The answer is 104.47751219 degree. The question asked me to round to 2 decimal places. 104.48 is this angle right here. The measurement from 0 to that red ray is 104.48. Now, I want to find the measurement for this green angle. I want the measurement from 0 to this green ray. This angle is 104.48. That makes this angle is 75.52. I'll take 180, subtract 104.48. That means this angle is also 75.52. So to find this green angle, I'll take 180 plus 75.52. That is 255.52 degrees. These are the two answers if my theta is in between 0 and 2 pi. However, in this problem, they didn't say it. That means theta is an all real number. That means my answer is going to repeat after every 2 pi. So my answers are 104.48 degrees plus 360K and 255.52 degrees plus 360K. Now, you might wonder, why didn't I use 2 pi k? Why did I use 360K? Well, this is in degree, so that's why I have to use the measurement for degree. One whole cycle is 360 degrees. If it's in radian, I will use 2 pi k. If it's in degree, I will use 360 degree k. And make sure that k is an integer. Example 7. Solve the equation cosine square of theta plus 3 cosine theta minus 1 equals 0. Theta is in between 0 and 2 pi. Give your answer in radians and round to 2 decimal places. This is my equation. Theta is in between 0 and 2 pi. I want the answer to be in radians and round to 2 decimal places. This is a trigonometric equation in quadratic form. How do I know? That is when your trig function is raised to a square power. If you have a trig function in quadratic form, I highly recommend you to replace your trig function with a variable. For instance, x or t or a or any variable that you would like to. So in this case, I'll let cosine of theta be x. And I will replace cosine of theta with x. So I have x squared plus 3x minus 1 equals 0. The reason why I do this so that it looks simpler and it's easier for me to solve for x. This is a quadratic equation. When you want to solve for a quadratic equation, you have two options. You can either factor this or use quadratic formula. This is not factorable, so in this case, I will use quadratic formula. This is a quadratic formula. You have x equals negative b plus or minus square root of b squared minus 4ac over 2a, where your a is 1, your b is 3, and your c is negative 1. So I'm going to substitute 3 in for b, 1 in for a, and negative 1 in for c. I am going to simplify this part inside the square root. I have 9. Negative 4 times 1 times negative 1 is positive 4. Then I'll have negative 3 plus or minus square root of 13 over 2. That means my x is either be negative 3 plus square root of 13 over 2 or negative 3 minus square root of 13 over 2. And what is x? X is cosine of theta. So that means I have cosine of theta equals negative 3 plus square root of 13 over 2 or negative 3 minus square root of 13 over 2. So my cosine is either be negative 3 plus square root of 13 over 2 or cosine is negative 3 minus square root of 13 over 2. I will put these into a calculator. When I put negative 3 plus square root of 13 over 2, I got 0.302775637. And when I put negative 3 minus square root of 13 over 2, I got negative 3 minus 302775638. You notice that I did not round these two numbers? Well, because they are not my final answers. I need to find theta. I only have cosine of theta. So whenever you need to use a number for the future calculation, please do not round them. You either use the exact form. If you would like to convert that into decimal, make sure to use all of the digits. Over here, I have cosine of theta is about 0.3. And here, cosine of theta is negative 3.3. Cosine of theta, the value for this cosine of theta, is in between negative 1 and 1. This value cannot be greater than 1 and cannot be less than negative 1. So this is going to be rejected. I am not going to take this answer because this is not in the domain of my inverse cosine. Now, I am going to use this equation, cosine of theta equals 0.302775637, to solve for theta. So to find theta, I will take cosine inverse of this number right here. Next, I will use my calculator to find theta. First, I need to choose the correct mode. In this problem, they want it to be in radian. And then cosine inverse of 0.302,775,6377. I get 1.2631926773. And this is my theta. I am going to round it to 2 decimal places because they asked for it. Is this the only answer I have? Cosine of theta is positive. That means theta is in the first and the fourth quadrant. So 1.26 is in the first quadrant. And we need to figure out what this angle is. So 1.26 is the angle from 0 to that red ray. And we want to find the angle from 0 to that green ray. The red angle is 1.26. That means this angle is also 1.26. I don't want this angle. I want the angle from here to here. One whole cycle is 2 pi. And I don't want this part. I only want this part. So I take one whole cycle, subtract 1.26 to get to the angle that I want. And I got 5.02. When you need to use pi for a calculation, please use pi from a calculator. Do not replace it with 3.14. For example, I will take 2 pi minus 1.26. That is how I got 5.02. These are the two angles that are in between 0 and 2 pi. In this problem, they only want me to find theta that is in between 0 and 2 pi. So that's why I didn't add 2 pi k in this problem. Example 8. Solve the equation exactly using a double angle formula. Cosine of 2 theta equals cosine of theta. This is my equation. They want me to give exact answer, and they gave me the hint that using double angle formula. And here I have cosine of 2 theta. This is double theta. That means I am going to use the double angle formula for this part of the equation. Let's go back to the formula page on 7.3. These are three variations of double angle formula for cosine. You can use either one of these. However, I am going to use this one. Cosine of 2a equals 2 times cosine squared a minus 1. The reason why, I will explain it later. The reason why I chose this variation because I want to match with this trig function on the right side. This is cosine. That means I want everything in this equation to be cosine. The other two variations has sine in there. Now, I am going to bring this cosine to the left side. I have 2 cosine squared theta minus cosine theta minus 1 equals 0. This is a trig equation in quadratic form because I have cosine squared here. So the first thing I'm going to do is replace my cosine of theta by a letter. For example, x. I will let cosine of theta be x. And I will replace cosine of theta by x. You don't have to do this if you don't want to. To me, it's just easier to look at. And you can always replace it back. 2x squared minus x minus 1 equals 0. You have a quadratic equation here. So you can either factor it or use quadratic formula. In this case, this is factorable, so I am going to factor this. 2x squared minus x minus 2 is factored to 2x plus 1 times x minus 1. And from here, I'll let 2x plus 1 equals 0 and x minus 1 equals 0. And I will solve for x from these two equations. I will have 2x equals negative 1 and x is negative 1/2, or x is 1. So I found x for this equation. X is either negative 1/2 or 1. And x is actually cosine of theta. So cosine of theta is equal to 1/2 or cosine of theta is equal to 1. From here, I'll look for the value of theta that makes cosine of that value equals negative 1/2. Also look for the value of theta that makes cosine of that value equals 1. Here is my unit circle. Cosine of theta equals 1. What is theta? Theta is right here. Cosine of 0 equals 1. So theta is 0. Cosine of theta equals negative 1/2. Cosine of theta is negative. That means theta is in the second and the third quadrant. At the angle 2 pi over 3, cosine is negative 1/2. And also at the angle 4 pi over 3. So theta is 2 pi over 3 and theta is also 4 pi over 3. So if theta is in between 0 and 2 pi, I will have 3 different solutions. However, they did not mention it here. That means theta is in the set of all real numbers. That means the solution will repeat after every 2 pi's. For example, cosine of 0 is 1. Cosine of 2 pi is 1. Cosine of 4 pi is 1. Cosine of 10 pi is 1. So from here, I need to add 2 pi k. So basically, theta is 2 pi k. The same thing with 2 pi over 3 and 4 pi over 3. And make sure that k is integer